I'd like to introduce Brooks Oliver. Brooks got his BFA at Southern Methodist University and finished his Master of Fine Arts in 2014 at Penn State. Brooks is currently a long-term resident at Archie Bray, which is where I had the pleasure of meeting him. And he's going to tell you about his process making 3D tools that then support the making of other things, and more than that. But Brooks, thanks for taking part in this, and I can't wait to hear your presentation.
Great. Well, thank you, Kelly. Like Kelly said, I'm Brooks Oliver. I'm a long-term resident at the Archie Bray Foundation. I want to thank you all for being here today. I also wanted to take this opportunity to thank Nsika and Shoji and Andy Brayman for inviting me to do this. It's an honor and privilege to be talking with you guys. But I saw this meme, actually, that kind of sums up my feelings on the day. Yeah, I think it's pretty accurate. The people in this room the past couple days are just like my total heroes. I literally met Del Haro last night, and I had this like fangirl moment. Okay, so my talk. My talk today is about using new technologies as tools and as a way to making tools. I'm mostly going to be talking about the 3D printer, but also the CNC mill and CAD programming. I kind of broke the talk up into 4 different parts. I want to talk about my work first so that you kind of know where I'm coming from. Then I want to talk about my process with the 3D printer, and then about the tools that I specifically make within my own work, and then tools that you can make to bring into your studio or potentially an education setting. So to start by talking about my work is an attempt to reimagine and reinterpret the familiar functional vessel. One could argue that the vessel, particularly the ceramic vessel, is very familiar to most people. So as a result, I try to provide the viewer with something that's familiar, but then I try to put a twist on it so that this thing you're looking at is both familiar and alien at the same time. So by isolating and altering and exploiting the necessary components that kind of make up a vessel, I attempt to provide new visions of like utilitarian wares. So within this piece, this is called the, over there. This piece is called the Fruit Loop. It's a fruit bowl, and it actually has no bottom to it. I wanted to make something that was more, that spoke about containment and could contain as more of a boundary or an edge, and didn't necessarily read as a fruit bowl. Similarly with this piece, this is terracotta, so we recognize it as terracotta, but we wouldn't necessarily recognize it as a fruit bowl unless we saw it performing. This is the puff bowl. The walls of this bowl actually carry more volume than the bowl itself, and the hole in the center drastically limits what it can contain. Within these vases, I was kind of asking myself, how can a vase present flowers in a different way? The one on the left is all about looking in rather than something coming out, and there's often this moment of discovery depending on how you approach it. While the vase on the right, I wanted to create a vase that enabled the viewer to see and appreciate the entirety of the flower. I tend to ask myself questions about what defines a functional vessel, and my pieces attempt to provide some sort of answer to that. Questions like, how can a vase have a hole in it and still contain? Or how can a vase present each flower it contains differently? Can a vase engage the floor and an edge as much as it does the table it sits on? Can a vase have multiple openings, or can a vessel have a super low profile in comparison to the flowers that it contains? Can a vessel be more of a line than a mass? Can a vessel be playful? In my mind, the vessel is all about like notions of containing something and transporting that. So the vessel is kind of all about inherent movement. But never really should a vessel move on its own, or potentially in an unexpected way, especially if it's made out of clay and something that's fragile. So these 4 pieces are part of a Wobble series, or part of my Wobble series, and they're about forms that actually have the potential to move on their own. They sit on a hanging table that has a pull handle, so the viewer is welcome to come up and approach the table and pull the pull handle, and then all the pieces start to move. I have a quick little video kind of illustrating that. And it's not playing. Nope, we're gonna skip the video. I'm interested in creating and exploring the context of how the viewer experiences the work. I want the viewer to be asking themselves questions to what it is exactly that they're seeing. Within this piece, I want the viewer to be asking themselves, are these tools, this table's at workbench height, it's made out of raw plywood and pipe. But at the same time, you know, is this something you're seeing in a design store or an architectural firm? This is from my fellowship show at the Bray. I made these 2 large hanging tables. But within the work and how it's presented, I want aspects of wonder and curiosity and play and theatricality to kind of come into the mix. So now for the reason that we're all here. Finally, my work attempts to blur the boundaries between technology in the hand and industry and craft. I utilize digital technologies within my work, specifically CAD programming, 3D printers, and CNC mills. This is my printer. Her name is Lulz. She's a TAS4 Lulz bot. This is not product placement, but I've had great success with her. So when preparing for this talk, I was kind of thinking back to past NCECAs, and I don't know if many of you guys are at the Houston NCECA, but Mark Ferris was in this panel called the New Modern panel, and he said something that really stuck in my mind, and he also said that these are kind of fighting words to say at NCECA, but he said that sometimes our field, and especially at NCECA, we tend to potentially over-romanticize the hand. And yeah, those are fighting words here, but I would agree. I do feel like we should romanticize the hand because the hand is capable of making beautiful things, as you know, I think all of our work would, you know, suggest. But for some reason, when it comes to the digital, a lot of people seem to automatically assume that the hand is removed, and I would very much disagree with that. And a friend and mentor of mine, Shannon Goff, would always talk about the term digital and how that actually stems from the term digit, which is of the hand. And that's something that's just always been in the back of my hand because I think the hand is very much involved within these digital technologies. But I'm fascinated with these technologies, but also enthralled with traditional ways of making. As ceramic makers, whenever we make something out of clay, I think we have to think about the context and the history of clay. That always comes into play with whatever we're making. But what's so cool about the 3D printer, and this is something that Tom Lauerman said, is that 3D printing is like nothing new. It's been around for a while, but what is new is that we can now, everyone can get their hands on it. Because of that, it's really interesting, I think, how it's embedded itself into so many different fields. Because it is new, it has no baggage necessarily, for lack of a better word, associated with it. So how it enters into our field, or design, or architecture, or the medical field, even like weaponry or nanotechnology, I think is interesting. So within my work, I'm really fascinated when you have this thing that has historical context and traditional ways of making, and it meets this thing that has no baggage associated with it. I think it creates a really charged gray area. So back to my process. This is my sketchbook. For those of you guys that work with CAD, you can probably recognize that my computer hates me. It's really hard for the computer to oftentimes render all of these objects at the same time, but this is how I prefer to work. It's kind of how my mind works. I like saying all these things at the same time. I use Rhino is where I build all of my models. I've been working with CAD for 7 years now. I learned it when I took a class with Tom Lauerman called The Digital Hand. And when I first learned CAD, I had no access to any 3D model, to any CNC mills or 3D printers or any of these like new technologies. And I bring this up because there's still many great things you can learn from CAD, even if you don't have like a 3D printer. So this is a form that I'm currently working on. It's a series of vases. And if I didn't have a 3D printer, I would use Rhino or a CAD program as a way of taking measurements, kind of making a blueprint, and essentially throwing this form on the potter's wheel. If it's not a form that's conducive to like throwing, I would slice it up into 1-inch sections and buy that great insulating foam that you can get at Lowe's or Home Depot. Cut out the forms, laminate them together, skim coat them in plaster, and gradually refine that form. And this is what I did for 4 years before I had access to 3D printers. And I still learned a lot. I've always drawn in CAD. So back to my process. Once I finalize a design, I send it to the 3D printer or to a CNC mill. I imagine that a lot of you in the room, especially over the past days, have maybe learned what a CNC mill is, but it typically works in a reductive fashion. That's one actually right there. You give it a stock material, and it carves out the form that you tell it to. And that's actually what I did predominantly when I was in grad school. So also, I went to Penn State, and Chris Staley had this quote. He has a lot of quotes, but he had this quote that process saves us from the poverty of our intentions. And it's something that kind of always sits in the back of my mind because the process of working with this equipment really influences the final designs of what I intended to make. So the image on the right is an image of the vase form that I originally wanted to make. And the image on the left is the foam that was cut out on the CNC mill. But working with these technologies, they set up problems, or there are oftentimes problems, and the mill couldn't carve something out that tall. So I cut it up in 3 different parts, and these became so much more interesting in my mind than the original form. And I actually never made that original vase, but instead I made these series of vases, which are so much cooler in my mind. I should mention it's not important to me for the viewer to know that my work is 3D printed. I actually go to really great lengths to remove any residual tooling marks from the prototyping process. And that's just my own preference. For me, they're a little too self-referential to how the thing was made. And I think this technology, as a side note, is going to be really interesting when we can't tell that something's 3D printed or CNC milled. I just think it's going to be really interesting. That being said, for me, rapid prototyping is a tool, and it informs the work. It takes me somewhere that I wouldn't have gotten without it. But it's not important for me, for the viewer to know that. So similarly, this was a tray form that then I made a mold of, I cast, and then it became this tray. I kind of cut it up and reassembled it. That then became these vases. That then became these vases. That then ultimately became that fruit bowl that was my first slides. And I work with molds. I find molds to be really freeing. They're kind of like, it enables me to have like 50 blank canvases that I can cut up and reassemble. And kind of a last note on my process, sometimes I feel like working with these technologies, we tend to think of them, or the viewer oftentimes thinks of them as a very linear process. And by that, I mean something goes from the computer in CAD to then it's printed and a prototype's made, then there's a mold, and then it turns into clay, and then it's done. But for me, I try to look at this process in a not so linear way, but rather as more of a dialogue of a back and forth between the printer and the clay. That the way in which I cut and paste my forms together definitely ends up going back into the CAD process. So in a way, the printer informs the clay and the clay starts to inform the printer. More recently, well, I guess if you guys have ever seen a 3D printer do its thing, it repeats the same movements over and over and over again until it gradually builds up a form. And this repetitive process has seemed to really kind of embed itself in my mind. So I started taking my casting slip and coloring it with mason stains. Then I've been extruding it back and forth on top of kiln shells that have alumina on them to gradually build up these forms. And I then fire them and I put them on the wall. So in a way, I've started mimicking my printer subconsciously, I realized. And these are, again, these are details of that. And I've also started doing it with pen and ink as well, especially as a way of just kind of like winding down at the end of the day. And within this drawing, I drew a line, and then I tried to make a line as close as I could right next to it without touching. And anytime my hand would waver, the following line would just amplify that mistake. And so then I took this image and I scanned it into the computer, and I used a feature called Live Trace on Photoshop. And I had the computer essentially interpret my image, and then I cut it out on a laser cutter onto large panels of wood. So in a way, I was imitating the printer when I made the drawing, and then the computer started to interpret my drawings and then actually made the final piece. I just find that back and forth to be really kind of fascinating. So now it's tool time, which is clearly a horrible joke. Yeah, it probably doesn't make sense to those of you that are under the age of 30. But okay, so specifically I want to talk about using technologies as a tool to solve the problems within my work and just make my life easier. This is my studio at the Bray. I show this image because I'm a tool kind of guy. I'm not a tool, but I'm a tool kind of guy. I studied engineering for 3 years in undergrad before switching my major to art. And as a result, I feel like I'm a fairly good problem solver, and problems oftentimes require tools to fix them. And I was reading recently that one of the main reasons that humans are where we are on the food chain is that what separates us from the animal kingdom is that humans have the ability to recognize problems and specifically create tools to fix those problems. And I just kind of find that to be fascinating. So I wanted to show you a series of pieces of mine that I had to make specific tools to actually bring them into the world. This piece is called Ruby Ruby. It's a vase. Water flows between all those forms, and I was trying to make a vase that actually didn't have a foot of sorts. But so this, the original form was milled out of foam on the CNC mill, and this was actually the first time I used digital technologies to make a tool. And this tool is pretty janky or dumb, I guess, but technology is the only thing that made it possible. And I have this video, and I don't know if it's gonna play. Oh, it's gonna play, great. So it's essentially a series of strings that have sponges at the end of them, and I was able to insert those sponges into the vase forms, and they would expand, and I was able to lift them up. And where the technology kind of came into play was when a CNC mill drilled all the holes that held the strings in place. And if they weren't directly lined up properly, it would have pulled the form apart, actually. This is a Wobble Bowl. It's a prize for the rib hunt, as a side note. I don't know if you guys have been searching for all the ribs, but yeah, totally. Just come to the VCU and the Crane Yard opening and the Bray opening tonight. But anyway, the problem within this form was that if I were to fire this to cone 10, this form would slump, and it wouldn't be able to rock back and forth. It'd have a flat spot, and it would warp. So with a 3D printer and in CAD, I was able to make a cradle that fits the form perfectly. So these two forms are cast at the same time, and then they dry together. They're nested in each other. They dry together. The bisque goes to cone 10, and then the glaze firing goes to 04. And I just use a commercial glaze, and I stilt it up. So at that point, the piece won't warp and distort anymore. Similarly, these Wobble Vases, it's a very similar thing. If they were to be fired like this, they would warp, they'd have a flat spot, they wouldn't be able to spin and kind of wobble about, and that illusion would be broken. So this is the cradle for it and the prototype. It's kind of funny because the vase is only a 2-part mold, but the cradle is a 5-part mold, and it never sees the light of day. It always just gets thrown into the shard pile after the bisque firing, essentially. And then it's glazed with an underglaze propped up, and it's either fired to 6 or 04. If you work with molds like me, you might really hate making them. They're a total means to an ends for me. So anything I can do to make my life easier when making a mold, I do that. So I've started printing the wells for the slip on top of the form. So the prototype is on the left, the final form is on the right, and the well casts in, and it gives me kind of a perfect guideline as a way of cutting out the form. Similarly with this, I'm only interested in casting that ring, and the wells are just attached to it, and I cast little plugs that I fill those well holes with, but you can kind of see the wells in that image. Or on the mold in that image, I should say. This is another Wobble Bowl. It's another mold trick. Instead of printing out a prototype and then painstakingly making a mold off of that, I've started just printing out the mother molds. And so for those of you that don't know, a mother mold is essentially a mold that makes a mold piece. So this is the form. When it was printed out, it was printed on essentially a bed that had keys on it. And so I was able to put coddles up, or walls, around it and pour the plaster into it. And it gave me these corresponding mold parts. that then fit together pretty seamlessly. This works really well for small casts, but once you get over like a gallon of slip, you're going to run into some leaking issues because that's not a perfect fit seam, but it's also great for press molding and plimping. Another tool that was printed for this piece, it was in the form of supportive scaffolding. So these were the prototypes with their wells attached. And I made this printout to essentially hold everything together while I was assembling it because I don't have 7 hands and I wouldn't be able to hold all those pieces together. So this is actually the piece, that scaffolding being used in the actual creation. I assemble everything upside down because it will warp that base if the clay is too wet. You can also use your print or your mill, essentially your print as a building platform. Ooh, too fast. So this was the original milled piece. It was the original milled piece, and I translated that into plaster, and then, which that's not always necessary. Sometimes you can use the print itself, but for this form I needed to translate it into plaster, and I essentially just build on top of it like you would any slump or hump mold. So this piece, I call it the 14-in-1 vase. It's potentially a really difficult piece to make a mold of if it's not divided perfectly. So when I went to make the mold, when I made the print, I printed it with little bitty walls between all of those tubes. And that made it so I could literally just pour the plaster directly on top of the piece, and the mold was divided perfectly. And those walls do cast in, but it's really simple to cut them out. And sometimes prints fail. This was a 44-hour print, and this happened this happened at 42 hours. Shout out to Bill Wilkie, who turned off my printer before something bad happened. But I show this because this technology is really far from perfect. I also can't seem to throw this piece out. I'm not really sure why I keep it around, but it speaks to me for some reason. And my mentor, Peter Biesecker, would often say it's okay not to know the answer, but it's not okay to not ask yourself the question of why you like something. So I keep it around, and I know one day it's going to influence the work. Those mistakes tend to. And I encourage people to listen to their mistakes. It's not necessarily a tool, but it's just some solid advice. That piece, which I call the Squiggle Vase, had to be printed in different parts. So this was the print on my printer, and then I assembled it like such. But this print failed 3 times, and this was actually the first project I took on with my 3D printer, and it was very sad to see that. But I kept all the pieces around, and I kind of treat them like Legos or building blocks to kind of, potentially see what I can make out of them. And so the silver assemblage in the front was actually the inspiration to that O vase, which is that ringed vase. And then the blue one in the back is actually inspiration for a current project I'm working on. So now I kind of want to migrate from talking about the custom tools that I make in my process and talk about easy clay tools that maybe are a bit more familiar and direct to the audience, but essentially tools that you can make with your 3D printer, and hopefully answer the question which I get asked a lot, which is how can you bring the 3D printer into the classroom? And these tools all they came about from a workshop I did at the Manchester Craftsmen's Guild, which is an amazing place. If you're ever in Pittsburgh, totally check it out. They just finished building this beautiful Fab Lab with 10 printers, and just the staff, everyone's just amazing there. But the objective of this workshop with working with the high school students was to teach them how to use CAD, and then to bring that CAD knowledge into the clay studio and bridge that gap between the digital and the hand. So we printed clay tools. So we started with rolling pins, which we just made as simple shapes, extruded them, twisted them. Then we made cookie cutters, which that's actually an assignment that Tom Lauerman gave me at one point, just to actually make a cookie cutter, which I use when I make my own cookies. But in this context, we rolled out slabs. We used the cookie cutter to cut out these slabs, and then we used those on top of a hump mold to build a form, and that pattern transitioned to the inside of that bowl. These are some examples of the cookie cutters that the students made. You can also make extrusion dies. I would do these almost solid, just as a side note for those of you that have 3D printers. The infill should pretty much be solid for those. They're under a lot of pressure. Then we made stamps and Sprigg molds. This is a stamp that one of the students made. And this is how she incorporates that stamp into her work. And Keith Hirschberger, who's one of the instructors there, he made this stamp, and this is how he incorporates it into his work. So on that note, I wanted to say thank you and invite, if you have any questions, comments, or concerns, throw them my way. Yeah, cool, thanks. Questions, comments, or concerns? Yeah. Oh, you mean like the tooling marks? Yeah. Yeah. So I used to, like if you're using ABS plastic, you can, just do like an acetone wash to it to get rid of those. For a while there, I was using laminating resin, like what you'd put on a bar top, and then sanding that down a bit. But more recently, what I've just started doing is making the mold, and then immediately, as soon as it's cured, the plaster is cured, I wet sand it. And it's just, yeah, it gets rid of them really easily. But I do get rid of those I do get rid of those tooling marks within the mold, because if you don't, like if you still cast it and they're a part of the cast and you sponge them off, those lines will reappear. So, but yeah, I do that. So,
did you hear that?
I think so. Will you repeat it just so everyone else does?
What software were you using and were you teaching the students to use in the last few pictures you just showed that showed the extrusions and the sprigging?
Totally. Good question. We were using 123D 123D Design, pardon me, which is a great program, especially if this is something that you're just starting out using. And it's a great tool to use when you're teaching children or young students. It's kind of like Rhino Lite, but it only costs about $10 a month to use. It's like a renewable subscription, so try it for $10. If you don't like it, don't resubscribe. But yeah, it's a great program, and the kids really seem to respond well to it. And this is Jill. She's one of the instructors, and she's in charge of the Fab Lab at the Manchester Craftsmen's Guild. So thank you for your help. Yeah.
So when you're doing, you're talking about doing a mother mold. Mm-hmm. I understand you correctly. That doesn't really work when you're trying to do like multiple piece molds because it doesn't fit together tight enough.
No, you can do like multiple piece molds. The problem I've run into is rather when you have a certain volume of slip that you're trying to contain, the pressure in there will really start to seep between those cracks because the two mold pieces aren't going to fit like perfectly together because they're not actually cast off of each other. But if you're press molding, it works great, and if you're slip casting small objects, it works great as well. I've seen it done like Rob Lugo, shout out to him, amazing artist, but he was making those large 4-foot urns, and he milled out one half of that mold, essentially. Not 1/2, 1/8 of that mold, and then essentially made 8 different pieces from that one mill that all assembled together. And he was press molding those, or plemping them, which is kind of something between slip casting and press molding. It's difficult, but it works.
You showing that one more complicated piece, and you said something about when you printed it, you made walls between. Can you explain what you meant there a little bit more? Yeah,
for sure. So this piece, to make everything significantly easier, if you look between those two tubes, I was able to divide that piece in CAD perfectly in half. So I could essentially make a 2-part mold off of this form. So instead of like going in with clay on the actual prototype and like, dividing it up so perfectly, and it might not actually be a perfect division, I was able to just print a very, very thin wall on the actual prototype of where that division should happen. And so I was literally able to just pour the plaster directly on top of that piece, and I didn't have to divide it like you would a classic
I think I
mold.
understand what you're saying.
Yeah, and those walls do cast in there, and you know, it's like a quick X-Acto knife. You know, they come right out. So, yeah. Sweet. Cool. Okay. Cool. Sweet. Well, on that. Cool. Thank you guys. I appreciate it.